Yes students, in the last class we discussed quantum free electron theory of metals. This model was given by Sommerfeld. He modified classical model and assuming certain facts, he gave the theory quantum free electron theory. The main features are electrons obey FD statistics and they obey Pauli's exclusion principle. So the main features of or added features to the classical features or features of classical theory. In that class, in the previous class, we also discussed Fermi energy, Fermi factor and energy density states. All these things we discussed there in the previous class. Now today, let us derive the expression for Fermi energy at absolute zero. What is Fermi energy at absolute zero? The energy corresponding to the highest filled level at absolute zero. Energy corresponding to highest filled level at absolute zero is called Fermi energy. See there the theory, this quantum theory, what it says is the metal is equated to a potential box of certain height. The barrel height is taken as Es. And electrons are confined to this metal box. They are arranged in different energy levels. They occupy different energy levels. The probability of occupation of the energy levels given by probability function or that probability factor. There at absolute zero, all the levels up to a certain or the levels certain levels up to a certain level, all the levels are completely filled and above are completely empty. So then, see the potential box at absolute zero, all the levels up to certain level completely filled, probability of occupation is 1. That level, the highest energy level up to which all the levels are completely filled, called the Fermi energy at absolute zero. All the levels above this Fermi level are completely empty, means probability of occupation is 0. Here L is the width of the potential box. The width is L. Now let us consider n number of free electrons in this metal box, confined to the metal box. Let these electrons be distributed in different energy levels, say E1, E2, E3, etc. And let N1, N2, N3, etc. be number of electrons occupying the energy levels E1, E2, E3 respectively. So in this way, all the electrons are distributed by obeying Pauli's exclusion principle. What is Pauli's exclusion principle? No two electrons, no two identical electrons can occupy the same level. To occupy the same level, they should have different spin. One having spin up, other one having spin down. Such two electrons can occupy the level. In that manner, the levels are filled in the potential box. Now, G of E dE, this represents the density function, energy density function, and it gives the idea about the number of levels available to occupy. Number of energy levels available in the potential box to occupy. And it is given by, see in the last class, I had given this equation. It is just assumed, no derivation of this equation, it is assumed. From this, we derive the Fermi energy. So this is the expression, 4 pi V by h cube, 2m to the power 3 by 2, e power half dE. V volume of this metal box, m mass of the electron, E energy corresponding to the given level. And it is written as C e power half dE, where C is, this value is taken as CE. Sorry, C. This is taken as C, the constant C. Now, number of electrons in the energy level E and E plus dE, denoted as N of E dE. Number of electrons occupy the energy range between E and E plus dE is given by the product of energy density function and the Fermi factor or probability of occupation, probability function. So that N of E dE is G of E dE into F of E. This gives the number of electrons occupying the energy range E and E plus dE or occupied in the energy range dE, energy value dE. So N of E dE, nothing but C e power half into, this is the probability function, 1 by e to the power E minus F by Kt plus 1. So that N becomes, N is now from this, let us find out the total number of electrons, expression for total number of electrons. What is total number? N. We have totally N number of electrons. So we get N as N by integrating this equation. Integration of n of e dE gives n. So integrate this expression between the limits 0 and E maximum. E is the variable, the maximum value is E maximum. It is taken as E maximum. Integrate, and here temperature absolute 0. So at T0 Kelvin, f of E is 1. All the levels up to Fermi energy, Fermi level are completely filled. All the above are empty. So that at T0 f of E is 1 and E maximum becomes Fermi energy, E f of 0. We denote Fermi energy as E f of 0. And you get f of E equal to 1 by substituting T and T in this equation. For that E less than E of T0, just consider this equation. E less than E of T0, so that E minus E to the power minus infinity, 1 by infinity becomes 0, so that f of E is 1. We discussed in the earlier previous class. So that n is this. Now C, keep C outside constant, integrate this. E to the power 3 by 2 by 3 by 2. This E to the power 3 by 2 divided by 3 by 2 between the limits 0 to E f of 0. Substitute, take E as E f of 0. We get 2C by 3 into this. Or here we substitute C. It is 2 by 3 into C into this. Now take this V this sign, n by V. N by V, number of electrons per unit volume. It is small n. It is given by 8 pi. When you simplify this, you get 8 pi by this, 2m power 3 by 2, E f of 0 power 3 by 2. Now take this term to the left hand side, this to the right. Then you get this. You know the method of simplification? No need to explain that. So you get this. Then E f of 0 means the right hand raised to the power 2 by 3. Now this is 3 by 2, so right hand raised to 2 by 3. Simplify, you get 3n by 8 pi h square by 2m. And this is the expression for Fermi energy at absolute 0. 3n by 8 pi h square by 2m. N number of electrons per unit volume. And if you plot the number of electrons in the energy range, number of electrons, it is a function of E. N of E as by against E. N of E versus E, we get the curve like this. At T equal to 0 Kelvin, at T equal to 0, all the levels up to EF are completely filled. All the levels up to EF are completely filled. Then above EF are empty. But at T equal to T greater than 0, what happens is, see here, the levels, the probability of occupation decreases. At maximum energy it becomes half. Then we see that some of the levels above EF are also filled. And this is the distribution of the number of electrons in different energy levels. And this is about Fermi energy at absolute 0.